So this is one of the videos linked to. So this is a Michael Falwell video.
Oh, well, we're back to fucking clowning around part 2. You had to watch this fucking 3 times last time, and you still didn't fucking understand it then, did you?
So this is all they can do. They can link to this crap. This, the blind deleting the blind. I could even make that kind of statement.
Ooh. You had to go there one day, didn't you? Bit of a low blow there. Thing is, I'm not mind blind.
They seem to be making some arguments about how efficient springs are. I don't know what number you come up with, because you don't really pin yourself down.
I know, I do pin myself down. I mean, obviously, if this thing only bounces 5 times on a spring, you can figure out that, well, the average is, okay, it's got to be losing 15% every time it bounces, right? I mean, come on, 20%, on average. So it's a huge amount of energy it's not returning. Yeah, that's the...
But that's not the argument, is it? You're saying when we put something on a spring and launch it. So where are you going with this? You're just changing the fucking argument, aren't you? The goalposts like you do.
To any sort of statements, therefore you can't be challenged on it. So I don't know what percentage you're saying. I think mindless marble.
Well, who tested this? So again, this is the joke, right? Yeah, we know a tennis ball is vaguely 25%, right?
To think that this hasn't been tested is just fucking moronic.
Ask Google, because no one studied it, so Google just said 25%. We must know it from some reference somewhere.
So again, we're talking about, you're talking about a tennis ball when we're talking about springs. So you're going to watch an experiment with a spring, which is the subject, and you're talking about fucking tennis balls. Or talking balls.
But the fact is, your science hasn't tested any of this stuff. It's indifferent to the whole subject. And the fact is that you lose more energy the higher the velocity. They haven't tested either. But I think the point is it's obvious.
Again, you think it's obvious. Why that is? Where have we tested this?
That you were saying they're about 70% efficient. Where you come up with that number, I don't know. But obviously...
So I said in the video, so this is a year ago. Like I said, I made a ton of videos on the subject. I pointed out all this stuff, so that's just lying again. It's just lying to say that I brought up the subject and I didn't use the tennis ball example, because that's exactly the example I used, was the tennis.
Yes, exactly. You used a tennis ball as an example for a spring. Seriously, I mean... What'd you say to that?
Oh. Fantastic, these things. So, if we were to take a mass and compress it onto a spring and then let it launch up, it will reach a height. And the height it reaches comes from the energy.
Makes me laugh because you sat there going, yeah, I totally get all this. You couldn't fucking imagine it a few weeks back, could you? It will drop back down. You said it's 30% inefficient. As you can see there, yes, there is a little bit of a gap, there is some loss, but it's certainly not 30%. And then, obviously, it's going to...
Where the hell is the experiment? What are you talking about? 30% where? Where did you show us anything here? What the fuck was that? What did he just do? I don't understand it at all. He's showing... He's got a stop on the spring, which I don't even understand. So... He compresses it, releases it, goes up to 6, and he says that's 7.5, which I don't even understand.
Don't beat yourself up too much about it, Goofy, fucking hell. This physics lot can be tricky.
And that somehow this proves how much energy was lost. I don't even understand how it could possibly prove anything. What the fuck was this?
Evidently, for you, it's just too taxing on your brain to understand. As you can see there, yes, there is a little bit of a gap, there is some loss, but it's certainly not 30%. And then, obviously, it's going to bounce back up, and that will show us how much energy there is left there.
And so it went higher. So somehow it made free energy.
What? It went higher and there's free energy? Are you watching the same thing as everybody else on the screen, or what?
How does this make any sense to anybody? Did you see what just took place? It goes up to 6, and then now it's going up to 8 plus. How does this make sense? I'm sorry, I can play it one more time, but I just don't understand it.
And it will drop back down. You said it's 30% inefficient. As you can see there, yes, there is a little bit of a gap, there is some loss, but it's certainly not.
I don't even understand.
It's going to bounce back up. Pulling that at 7.
Right. So it's a full centimeter less.
No, it's not. It's half a centimetre, as you can see in the video.
Well, the whole point of the experiment was to first drop an object onto the spring, compress it with a known amount of energy, and then see if it returns to that same height, which would indicate it conserved all of the energy. And that's where you're going to fail dismally.
Really? I could try that one out.
You compress the spring, you let it go, boom, and it goes to a height. So the energy came from the spring. That's how it got there. Then when it gets there, it's in gravity then, and it's going to fall back down. So the potential energy in the spring.
So there's no potential energy in the object, but go ahead. And the spring already used it.
No, there isn't any potential energy in the object. It's now converted to kinetic energy. That's why it goes up.
It's energy, and it's oscillating, so it still hasn't used all of its energy, obviously.
Converts to kinetic energy, it goes up, and that stores as potential energy.
Well, whatever. That's all the part where I say you're just making that crap up. There's no scalar energy. There's no kinetic energy. There's just the momentum. You're just going to return the amount of momentum.
Right, so again, you're saying momentum is in a spring. What's your formula for that? What's your equation? I'd like to see that one, rather than you just stating momentum in a spring. How would you formulate that? How much momentum? You know, you've got to compress a spring. How are you calculating the amount of momentum stored in a spring? And if it's stored in a spring, wouldn't that be potential momentum, because the spring would be compressed and not moving? So that would have to be potential momentum, wouldn't it, in your world?
That's what's stored in the spring, is an amount of momentum.
In gravity. Now, it's going to fall back down, and as it comes down, it's going to land on the spring again. Now, if your claim is that it's the 70% inefficient, so as this is launched up, if there's, say, 100% of energy here.
The thing is, you watched this, you didn't understand it last time, and now you can see that you're not even listening. You don't understand because you're not listening.
And only 70% of that energy goes in to launching that mass to that height. As it comes down, there won't be enough stored potential energy in gravity for it to compress the spring anywhere near down to what the original compression was of launching it.
So this was great, right? This is just so freaking clinical and brilliant, right? No.
Yeah, but you didn't. You still don't understand it, do you? All you can do is just be fucking snarky and smug when you haven't got a fucking clue.
So far, oh, duh.
You know, you should see some significant
Oh, what a pisser. Oh, duh, like, yeah, this is really simple and I understand it. But you don't.
difference. You know, as it comes down, it's going to be, you know, there's going to be some visible difference that it's not compressing the same because there was a loss of energy when it was launched. Obviously, there is going to be some losses because we have air resistance and we have friction. You know, it's not a frictionless environment. And obviously, we've always got air to contain.
Because we can just show you Steve Mould's experiment where even in air, okay, and even without a cement floor, you can get a ball bearing to bounce 250 times. Obviously, not that inefficient. That's less than 1% loss per bounce.
But again, you're changing the argument. The argument is when we compress a spring, put a mass on it and launch it, that all that energy doesn't get into that mass. We don't care how many times it fucking bounces. That's not the argument. You're changing the argument into something entirely different. And yes, if we were to put a mass on a spring and let it, you know, harmonically oscillate, yeah, it'll go for a long fucking time.
So there's going to be some energy losses, some percentage. I don't know what that would be.
Right, so what use is this video as proving anything?
Because it's a demonstration, actually measuring things. But again, you don't understand that, do you?
Oh yes, no use at all.
Again, I could just do like you could just come up with a figure because, oh, you know, that you're going to get, you know, 20% loss or 5% loss, you know.
I didn't come up with one. I came up with the fact that science doesn't have one. I researched it. I couldn't find any information
You researched it, you Google searched it.
Anywhere that studies this phenomenon. Nothing. Zero. Not a single.
The reason there is no information on what you're saying is because it isn't fucking true. They understand how much energy is stored in a spring. There's a formula for that.
Physicists talking about it. Nothing. Zero. That's not my bad. That's physics' bad. That it doesn't even acknowledge the existence of this phenomenon. So
it's a phenomenon in your mind that you've invented, and now you're holding on to it like some little weird comfort blanket.
Springs, and it doesn't acknowledge that springs don't go anywhere near the idealization.
Just make a figure up, but you know.
Fucking 90% is pretty close to the idealisation. 90 to 95%. I mean, fucking hell. How much more do you want?
Realistically, there's going to be some energy loss as we launched up, because it's, you know, it's going in the up. It's travelled up there with some friction, and our resistance it's travelled down with some friction.
So, and we know when it's going fast, it's going through the gravity quickly, and when it's going slow, it's going through the gravity slowly. And so,
oh, we're not even going to listen to that fucking bullshit. Oh my god!
And that, even that, I have to keep defending this fact that it's 9.8 meters per second of added velocity per 1 second. That's
well done. Correct. So what? Is that some sort of revelation?
The actual gravitational formula. The fact that you people won't even acknowledge that obvious truth is so...
It is true. Nobody's denying it.
Glaring.
And our resistance. So it's not going to be perfect, but you're saying there's a good, 30% loss in efficiency again. Don't know where you come up with that number, because I'm pretty sure you haven't tested it.
So I don't know what this lie is about this 30%. I don't think I ever argued it was 30%, but whatever. I said it could be as bad as, maybe.
Well, that's saying the same thing then, isn't it?
Because you don't test anything.
It's all a big lie. It's not my obligation to test anything, frankly.
And make stuff.
No, that's your science. I didn't know. I asked your science, what's the answer, and they didn't have one. Fact.
Because there's not a problem with it. That's why there isn't any information on it, because it's not an issue.
I would have used their answer. I used Google's best answer. That's all I could get from science was Google's best to guess. I didn't do anything wrong here. I didn't do anything. I didn't try to deceive anybody. I was trying to get the real answer. Your science doesn't have the real answer. That's the absolute fact, retard. That's why...
But again, there is no answer. You're chasing fucking pot of gold at the end of the fucking rainbow.
Your video is the only video on the subject, right? Except for me talking about it. Now you're the...
Oh, like nobody's ever done this. Jesus, what a joker.
Suit your argument, I suppose in your world, if they were 70...
It's all this time wasted on, stuff that just couldn't make a difference. 20, 40, 70, who cares what the number is? You're going to prove something, so go ahead and prove it.
Percent inefficiency would,
You've already seen this. Not too long ago. Have you got like some kind of fucking memory problem?
Play to your ideas, but again, these things can be tested, so we'll move to that.
Yeah, thank you.
This footage is from another experiment, but I thought it'd be useful here.
So it'll be useless here, okay? Because what it won't show is how quickly it dampens to nothing. So it's going to lose all...
But that isn't the argument, is it?
...of its energy to this inefficiency. So it's not going to bounce and keep bouncing. It's going to lose a ton of energy, then a ton of energy, then a ton of energy, and then stop moving. That he's not going to show us.
Initial...
No, because that wasn't the argument.
I'm calling 0.75 centimetres, and then it's launched to a height. I'm calling that at 7.5 centimetres, so that's its maximum height. Now, I froze it, So I don't know what the 7.5 is. Why is he saying, so he's going towards, he's just...
It's the centre of it, the centre of mass, because when you accelerate something, it accelerates from its centre of mass.
Arbitrarily defining where the middle of this thing is, when he should just say, okay, it's 6. Yeah, the bottom line is 6.
I have an anti-gravity here. I've freeze-framed it, and it will drop back down. You said it's 30% inefficient.
So the spring doesn't get all the way compressed. So that's another, you're saying, what the hell?
Yes, that's the whole point of the demonstration again. See, this is how fucking stupid you are. You're watching it for a fourth time now, and you still haven't got a fucking clue.
Dropping something on a spring and not allowing it to compress all the way. That's a little bit weird. But anyway, it doesn't really matter because we know it's not going to keep bouncing.
As you can see there, yes, there is a little bit of a gap. There is some loss, but it's certainly not 30%. And then obviously it's going to bounce back up. and that will show us how much energy there is left there, and I'm calling that.
So I'll call it 5.5. No, it's really 5.3.
You can call it whatever you want, but everybody can see it.
So you lost, whatever, 0.7, and out of 6 units. So you're talking about more than 10%. So it's more than 10%. And like I said, if you let it keep bouncing, what are you going to see? And we know, again, just understand, this is the part where it loses most of the energy, where it's going the slowest. So the 0.7 here.
So you say.
Would be, 15 in this faster range. So it's much more energy lost because of the fact that this is how much energy it's missing at the top portion. The top portion is the slow.
So you're just talking absolute bollocks now and trying to eke out more and more energy loss through talking absolute fucking bullshit.
Lowest portion. That's the portion where it's fighting the gravity the most friction, you could argue.
7 centimetres, so we've roughly got a difference of half a centimetre, 5 mil. Again, I froze it there. We're not doing anti-gravity.
So it's more than half a centimetre, obviously, but whatever.
Gravity, and then it's going to drop back down after that. The slow-mo runs out.
Oh yeah, so conveniently the slow-mo runs out, but
not conveniently, it run out. It's you get a small window to record. That's it, because you're recording things happening fast over a very short period of time, and that's all it allows you. No fucking mystery to it.
He could show us it bouncing and just show us how many times it hits, bounces, and it'd be less than 10. So we
yes, I could show you that, but that is not the argument.
know that it's more than 10% of the energy lost per bounce. Simple enough fact.
Just the idea that also was taking the measurements roughly from the centre of mass.
So this isn't going to have anything to do with putting a light mass versus a heavy mass. So we're not going to see the difference.
The whole point of this was it was quite a light mass. It was less than 25 grams, but probably about 24.25 grams. Because you keep saying they're really, really heavy because the sockets. No, they are linear bearings. It's not a socket out of a socket set. It's a linear, low friction bearing that slides up and down these rods.
Difference between pushing a light thing and pushing a heavy thing, which is the real argument, is how much more efficient it is, how much more inefficient the spring is, the lighter the object you are pushing. So the whole argument is that it's all about the weight of the object you're pushing. And the heavier it is, the less energy you'll lose. The lighter it is, the more energy you'll lose. So he used a pretty heavy socket on what looks like a pretty lame spring. So we know.
And again, lies. It's not a fucking socket. You must have said this fucking, I don't know how many 100 times. You know it's not that. You just lie. And lame spring. Whatever spring we used, it'd be fucking lame. Because your fucking brain's lame.
This is the heavy version, and this will be a lesser version. So if it's 10% at a heavy thing, it might be 15, 20, 25% the lighter you go. So this is.
It might be. So again, you're just making shit up.
Just to get more distortion, let me lie to people, confuse the subject, and pretend it's not significant when it's very significant.
Initial to the centre of mass final. Calling the initial start position 0.75 centimetres. We've got a travel of 7.5.
So the 0.5 is a lie, right? You could just see it was obviously, 3, not 5. So it was 7 that was missing.
So we take the 0.75.
So I'm saying it was half a centimetre difference, and you're saying it was 7 mil, like that's some kind of gotcha, which still works out at around about 90% efficient, which is basically what I said in the video, between 90 and 95%. My results were 93, which is somewhere in between.
Off the 7.5, and that gives us 6.75 distance. So that was for the first launch. As it came down, bounced again. We'll go with the same initial because it was practically there. And it got to 6.2, got to 7. So minus the initial, we got a travel distance.
So all we know is the differential based on 6 units. So again, 6 units, you lost 0.7. So that's over 10%. And that's if you think the friction or the pressure is linear.
I don't have to think about that one because I understand that it is linear, unlike you.
the pressure isn't linear. Gravitational pressure isn't linear. Because in the first 3/4 of the voyage, you were going much faster.
6.25. So there's a difference of half a centimetre. Fine.
So again, it wasn't a half a centimeter. So if I have to go, I can go back in the video, but clearly it wasn't half a centimeter. It was 0.7 of a centimeter.
Millimetres.
Okay, 0.7, whatever. It still doesn't really make any difference, does it?
What you want to say? So the two distances, so 6.25 divided by 6.75 equals 0.9259, which can round up to 93. So
if he would have used 0.7, obviously it would have been more like 87% efficient.
It'd be around 90.
And that's with a heavy object. So how inefficient will it be when you go lighter and lighter? Oh, we didn't do that experiment, right?
93%.
Oh, you're such a trier, aren't you?
So after the initial launch, and obviously incurring some friction there, coming down, incurring some friction there, resistance there.
So the argument would be he's saying it does bounce 10 or 12 times. If I just let it go.
No, I didn't say that, did I? You're putting words in my mouth.
Oh, and let it bounce. It'll bounce 10 or 12 times. It won't bounce that many times. And he knows.
Being back up, and again, incurring friction, we have 93% efficiency. So which is nowhere near the claim.
Yeah, well, this obviously it is very near the claim in the sense I never claimed it was the same amount regardless of the weight of the object. The whole argument is that it gets worse and worse and worse the lighter the object you're pushing. So you.
Well, this was a light object. That was the whole point. Again, you missed. Or pretended not to understand, like you do.
Didn't do a lighter object, did you? No, you didn't. So it's not even relevant to the subject. But you've conceded it's 93%. I'm going to argue, well, let's go back. I mean...
Yeah, it's... Like I say, if we go with your 0.7, we're looking around about 90%. So... Which is basically what I stated in the video, between 90 and 95%. So, no gotcha there, is there?
It's not that hard to go back. And we just look at his lie, right? Because it's just a lie. Where the hell is the actual experiment? There it is. All right, so we know the bottom of the weight went to the 6th line, right? That's pretty much, right on the 6th line. All right, and so then the second iteration, all right, is here. So let's finish that.
How much energy there is left there, and I'm calling that.
So there you go. I mean, it's quite obvious that that's not halfway between the 6 and the 7. It's like 3. So there's 7 missing. 0.7 is missing, not 0.5. So again, cheat. So he's got his cheats.
So, yeah, you're arguing about 2 millimetre. Unbelievable.
I mean, you can really see it on this side of the scale. That's almost a 2 there. So clearly it's not a half centimeter missing. It's more than a half centimeter. All right. So just, the fact that he had to lie about that part.
I'm not lying because it's there in front of you. You can see it. So I'm not hiding anything or disguising anything, am I?
Obviously, if he used 0.7, then he's, like I said, he'd be somewhere in the 80s, okay, in terms of the efficiency. And I argued the tennis ball was 75 efficient. So, we're just now saying...
Yeah, you argued it was 75% inefficient, and it's actually way less efficient than that.
Okay, what happens when you use a lighter object? So that's...
This was a light object, you moron.
A big lie.
We're not talking about...
This is the quality of rubbish video they say I must debunk. I must show up to debunk all of the...
Nobody asks you to debunk them, and you don't anyway. You just rag on them. You can't debunk them because you don't even know what you're fucking looking at.
This noise made by these flat KEers, the KE truthers. I have to show up and debunk
KE truthers, oh my.
Every one of their silly, contrived piece of crap lie videos. And this is a lie video, right? We know he didn't do the right number here. It's obviously not half. It was obviously not a half centimeter. So he had to cheat right in front of us. Okay.
Again, how's it cheating when you can see it? You've just played it. You've just shown it to people. So how's that cheating, dickhead?
The number. And it's still 93% is a big number for a heavy object.
fuzzy feelings here. We're talking about data points, actual real-world evidence.
Okay, so real-world contrived lie evidence. Okay, so he lied about how much it was deflected, and then he's lying about the fact that the real argument is that it gets worse the lighter the object. That this amount of waste or loss increases the lighter the object you're pushing. That's the whole point. The point isn't that you lose some energy. If you lost a consistent amount of energy regardless of the experiment, that would be fine. The fact that
Well, we're all sorted then, aren't we?
you're not losing a consistent amount regardless of the mass, that's the part that makes the experiment bogus.
So your claim of spring inefficiency doesn't hold, does it? Also, I forgot to mention,
Liar.
obviously, the weight of the mass. It's less than 25 grams. So.
Less than, like 25 grams isn't any weight or something. So we know it's a piece of steel. So we know it's not an insignificant mass for the spring you're dropping it on.
Not heavy.
I wasn't dropping it, I was launching it. And so now you're basically saying it's not less than 25 grams when you've seen in other videos I've weighed them God knows how many times. So again, there's more lies.
Not, I don't know what your class is light mass. If we've got to extract some atoms and launch them, I don't know if we've got to go that light. But
the point is, it gets worse and worse the lighter you go. So what's complicated about that argument?
It's not complicated. It's just you keep saying it when you've got no evidence for it. Where's your proof of this?
It gets extremely bad if you go with an atom or a piece of styrofoam or a piece of dust. You lose 99% of the spring's energy.
Oh, okay, you lose 99%. You do realise as well, when we're launching these things, the spring, you do it within like some sort of limitation. I wouldn't put 3 tons on that spring because it'd probably completely bottom it out and it wouldn't go anywhere. And then if I was to put a speck of dust, again, you're talking complete nonsense. You're not talking within a realm of limitations, are you? You're just getting from one extreme to another to try and prove some fucking bullshit you made up.
That's the whole point. It's 90. The piece of dust is 99, and then you just go down to heavier and heavier things. And if you were moving an elephant, then it would be 1%.
What if I put a fucking elephant on it? It wouldn't move at all. It'd just bottom out. So again, you're talking absolute nonsense.
In my mind, 25 grams.
Because it's all about the velocity of the spring. When the thing leaves, obviously the higher the velocity of the spring, the more energy is still in it. The slower the velocity, the less energy is in it.
Isn't particular.
And again, you just keep claiming that. But where's your evidence?
Heavy, because your contention was that lighter the mass, the less energy.
So again, he's arbitrarily defining it not a heavy thing. So a steel socket isn't a heavy thing, he's saying.
Would get in.
For the size of the spring, I'd say it was pretty heavy. I'd say it weighed 100 times the weight of the spring.
You're saying the linear bearing that weighs 24.25 grams, you're saying the spring weighs 100 times less than that. So you're basically saying the spring weighs 0.02 grams, which is, I don't know, that's pretty light. Maybe a grain of salt or something like that. So again, this is how retarded you just make shit up.
Pretty heavy.
Into it. And clearly that's not the case, is it?
All right, so that was it. That was their brilliant video. So there is another one. I'll go find that.
Their brilliant video. Who's they, them, there? I made that video. Me, here. Talking now. But the men in black didn't come round and say, oh, you've got to make a video because Goofy's, getting on to these physics things and he's going to upset the physics world. You must make a video for us and put it online. I mean, it's just conspiratorial fucking bullshit there. So to sum up, you made some baseless, unevidenced assertion about the efficiency of springs. You saw a real physical experiment that proved you wrong with measurements, and in light of seeing that evidence, you strawmanned your own argument, and then right at the end, you threw in a little bit of conspiracy as if the world's against you. Couldn't just be that you're an absolute fucking retard, could it?